Theory of plate tectonics. Then we have transform boundaries, and a transform boundary is a region where two plates just simply slide past each other. So you may have one plate going this way, and the other plate would be going this way. So these are named for the way Earth's crust changes or transforms its relative direction and velocity from one side of the boundary to the other. So again, this is transformed here because you have this going this way, you have this going this way. So the Earth's crust is changing directions here. These are characterized by long faults and shallow earthquakes. The crust is only deformed or fractured along transform boundaries, not produced or recycled. So you don't have new crust formed like you would at a divergent boundary, and you don't have crust being recycled like you would at a convergent boundary. Again, new crust is produced at divergent boundaries, crust is recycled at convergent boundaries. So you don't have new crust produced or crust being recycled at these transform boundaries. They simply slide past each other. Some of these faults, you basically have a piece of land moving, in this case, kind of off to the northwest, and one moving sort of to the southeast. And basically, you end up with a lot of earthquakes along these as these sort of stick together and then slip. They stick and then slip and then stick and then slip, and that causes your earthquakes. So some of the damage caused by these earthquakes, you can actually have breaks in things like highways and stuff like that. So a lot of this, you can kind of see the fault line kind of running right through here where this is broken. So most transform boundaries cause sections of ocean ridges to become offset. So in the ocean, the ridges won't be a straight line. They're going to be offset because of these transform boundaries. The transform boundaries also occur on continents, and the San Andreas Fault is probably the best known example of this. And the San Andreas Fault basically separates southwestern California from the rest of the state. The San Andreas Fault is responsible for many of the earthquakes that strike California. So offset railroad tracks, roads, and fences and creeks are signs of a transform fault. So you may have a stream or something that kind of flows and then takes a big jump and then kind of keeps flowing. That's a sign of a fault there. So earthquakes and tsunamis. So earthquakes can cause tsunamis. So large ocean waves created by vertical motions of the seafloor are tsunamis. Okay, so these are very large ocean waves caused by the seafloor moving. These are mainly associated with underwater earthquakes. So the underwater earthquake displaces water over the fault. So when the earthquake happens, the water will basically rise up, and then that wave expands out from that point of disturbance. So the disturbance spreads out as extremely long waves that break on shore with heights exceeding 30 meters. So you have your point of origin here. So you have your earthquake, which displaces the water above that, and then that wave moves out from that original point of disturbance. Tsunamis can devastate coastal regions by having waves come far inland with a lot of force and then basically flood areas, wash things away, etc. One of the first signs that a tsunami is coming is that the water on the coast, the low tide, basically, or the water will kind of be sucked back out to sea before you have the tsunami come in. Okay, so the water kind of gets sucked out and then kind of comes back in as a big wave. That's because one of these valleys of this wave kind of hits the land first, and then that kind of sucks the water out, and it kind of comes back in as your tsunami.